All right, everyone. Thank you so much for joining us. This is a wonderful full room to see. I hope you're here all to get the introduction to Couchbase. Hopefully some relatively new folks in the room, so this should be a great introduction. My name is Perry Krug. I'm one of the principal architects at Couchbase, and I'll be the MC for today's session. And without further ado, I'll introduce our first speaker, Mr. Aaron Benton, who will be kicking off the introduction to the platform. So thank you very much.
Thank you for the introduction, Perry. Glad everybody's here. Hope you guys are ready for a great full day of a conference. Today we're going to talk about navigating the Couchbase Data Platform and give you just a small overview of all of the various different components of the data platform and give you a little bit of information leading up to all the other sessions that we'll be having throughout the day today. So like Perry said, my name is Aaron Benton. I'm a solutions architect here with Couchbase. And today, for our agenda, we'll cover architecture, services, and a little bit of security. So the data platform, we saw the wheel earlier. This really encompasses everything that Couchbase is and everything that we have to offer, from unified programming to big data connectors and SQL, container and cloud deployments, full stack security from end to end. Right, starting on the outside, we have key value, indexing, full text search, analytics, query, eventing, mobile, replication. But at the core, all this starts with a memory-first architecture. And it's a shared nothing architecture. We provide workload isolation through multi-dimensional scaling. And with even on the key value, which we're getting ready to look at next, we'll have inter-cluster replication as well as XDCR. Full text search, again, inverted indexes. Ravi talked about this a little bit earlier today. Operational analytics, and our new service, new multi-dimensional scaling service, eventing. But before we dive into those, I want to look at the architecture of a single node of Couchbase within a cluster. I know it might be a little hard to see there because of the lighting in the back, but when you install Couchbase, all of the services that we've talked about and you'll hear about throughout the day, data, indexing, query, full text search, analytics, eventing, are all shipped within that same package. Okay? So all of these individual services have their own discrete architectures and functionality. And when you install Couchbase, it's on that given node, you're joining it to a cluster, you're choosing what services you want to enable or disable. And Munib is going to go a little bit more in depth into multi-dimensional scaling and sizing and configuring your clusters in the next session. But it's really important to note, these are not separate installs. I don't need to go install the query service, or that's a separate download, and I need to go download and install the full text search service. All services are available. It's what you're choosing to enable when you go and configure Couchbase. But at its core, we have the cluster manager. The cluster manager is going to be present on every single node, regardless of which services that you are running on that given node. Okay? And the cluster manager is a multi-process architecture that handles things like security, role-based access, auditing. It powers the administrative UI, the entire REST API, stats, log gathering, alerting, things like this, as well as node communication and configuration. So everything with Couchbase and all of the different services are exposed through the web API on any one of the given nodes that are a part of your cluster. Additionally, all of this configuration and everything that you can do through the web UI, you can also do through the REST API. So if you have your own set of scripts or automation in terms of how you want to bring up clusters, configure clusters, perform maintenance operations, etc. All of these operations are exposed through REST. So you're able to automate it and mold it to fit your deployment processes and procedures. So key value. For the key value service, this is kind of the core of Couchbase, right? This is where we started at. The key value is a memory first. Right? All reads, all writes, inserts, updates, etc. happen to memory first on the node that they're being written to, okay, before disk. So it's going to guarantee you're going to get sub-millisecond response times from your SDK operations. This also is what powers local queries, right? Local indexes, which is what we've commonly referred to as views that scale specifically with the data service. Views have been succeeded by Nickel in terms of a multi-dimensional scaling service and a whole new way to interact with JSON by using SQL. But for the key value service, we talk a lot about JSON, right? The key value service, though, in documents are not limited to just JSON. It can be any type of data, binary data, strings, integers, etc. And this memory-first architecture is what powers everything with Couchbase in terms of all the other services that we're going to look at. As mutations happen to the data service, they flow freely amongst all of the other services in Couchbase, right? Global secondary indexes, full text search, analytics, eventing. That mutation, whether it was an insert, an update, or delete, is flowing through all of these other services asynchronously. So when you do a mutation, you do a write, you send a new document to Couchbase, your application gets a response, but that mutation is going to continue to flow throughout the entire Couchbase ecosystem, being delivered to indexes, full text search, eventing, etc. So documents, as we talked about, are primarily, you expect these to be JSON. They can be, again, any data type. Documents are written into what we call a bucket. All right? A bucket is just a logical namespace for where we store documents at. Okay? And these buckets are distributed evenly throughout your cluster. And for a bucket, what we do is take that bucket and we divide it into 1,024 virtual buckets, or what we call vBuckets. And those are distributed throughout the cluster. So take a scenario where we have, let's say, 4 nodes of Couchbase running the data service. We would have 256 vBuckets, virtual buckets, that are on each node. And that's what that node is responsible for. And if we had configured our bucket with 1 replica, right, we would additionally have 256 replica vBuckets that are distributed evenly throughout the cluster. So in total, in the case of 1 bucket with 1 replica, right, we would have 2048 vBuckets that are Hear me now? All right. So we're just going to hold the mic the rest of the time. That's fine. Yeah. This is high availability, right? All right. So that data service. Again, with the data service, the last thing that it powers I want to touch on is XDCR. How many people in here are familiar with XDCR and what it can do? Just a couple? Okay. How many people in here have a DR environment? How do you get data from your production environment to your DR environment? Right? Different means of replication. That's what XDCR is, right? Cross data center replication in Couchbase. XDCR, though, is memory to memory from one cluster to another cluster, right? And as that mutation happens on your primary cluster, it flows through, right? Your application's responding, it's moved on, doing whatever else it needs to do. That mutation is flowing through DCP and ends up getting picked up, sent off through XDCR, right? And one of the biggest bottlenecks, I guess, with replication is time, right? How fast can we get that mutation over there? And this is where we start talking about eventual consistency and things like that. But for Couchbase and XDCR, that mutation is about 2 milliseconds or less over WAN speed. Right, so however fast your connection is, that's how long it would take for that document to go over. That is insanely fast active-active replication. Query and indexing. So our motivation for JSON was to give developers and enterprises an expressive, powerful, and complete language for querying, transforming, and manipulating JSON data. And you heard Ravi talk earlier today at the keynote about the power and the flexibility that Nickel, a SQL-based language, gives you. So for query and indexing, right, our query engine is highly parallelized, right, multi-stage, and we'll actually look at every stage in the pipeline that we go through. We support a full standard SQL pipeline. Memory optimized live indexes, so we give you two types of indexes, memory optimized indexes or global secondary indexes. Read your own writes with tunable consistency, meaning at request time, your applications can choose the consistency that they want from a given query. Right? By default, we want to make that as fast as possible, but you're able to tune that to your own SLAs. So as an example here, we have a customer who has purchased, has two different purchases or orders, right? What we're able to do is a simple select statement where we want the email address and a count of the orders from our purchases bucket that we are going to perform an inner join on the customer's bucket using the keys from the purchases bucket where the customer ID is a property in the purchases bucket. That property, that value is the document ID in our customers bucket. And we're going to group those results by the email address. This query would make perfect sense to anyone coming from a relational world, but we're actually operating on JSON. Full query pipeline support. So stepping through this, as I know it might be a little hard to read there because of the lighting, when a request is issued, we parse that query, we come up with a query plan, we perform a index scan, one of the various different index scans that may be there, index scan, distinct scan, et cetera. There's about 15 different types of index scans that can be performed. An additional fetch that we perform on here, going to the data service. Why do we need to go to the data service? Well, unless an index fully covers a given query, meaning all the fields that we're returning and also that are part of your predicate, if you did not have all of those in the index, whether that's because of different constraints around performance or the overall size of the index, right? You wouldn't want to necessarily put 50 different properties in your index, increasing the size. Based on those results, we would potentially need to go to the data service and fetch each of the individual documents that were a part of the predicate or necessarily being returned and get the appropriate data to do any joins, any additional filtering, right? Any pre-aggregation or aggregates that are happening. Then we have to potentially sort all of this data if it is not already being returned from the index in an appropriately sorted manner. We would need to sort those. Lastly, applying any offsets or limits to that given query. And then we have our final projection, which is then sent back to the client. Global indexes, again, indexing in general is a multidimensional scaling-enabled service, meaning when you bring up a single Couchbase node that we looked at earlier, you can choose to just run the index service. And you can tune that hardware, that processing, that memory to that specific node to get optimum performance based on your configuration and SLAs. So this work is isolated. Right? Again, we've talked about that mutation happens on the data node. That mutation then flows through the data platform until it gets to the appropriate index node, and then that index node is doing that work asynchronously. Right? That update that your application made is not affected by the indexing that is subsequently going to go on downstream. Indexes are created using exactly what you would expect, a create index paradigm. I want to create an index with this name on this bucket on these fields where whatever additional predicate values that we would have, right? Additionally, indexing we think of as root level properties, right, at the root of our JSON document. In Couchbase, those can be completely nested properties. And in fact, we can even index arrays of nested objects appropriately. Extremely, extremely powerful. So when we start to talk about high availability in redundancy, one of the things that we need is replicas. By default, an index is assigned to a single index node in the cluster. That index node is not distributed across multiple different index nodes. When you start talking about things like range scans, it's not always as efficient to have that data separated, right? So what we want to be able to do is have replica indexes. And with Couchbase, as of Couchbase Server version 5, you can say with num replicas, and we will automatically create and manage a replica, a copy of that index for you on another index node that you have configured in your cluster. And that serves two purposes. Where one index node goes down, that's fine. The query service knows here's all the indexes that I have available. I'm going to pick one and use it. So if that index node goes down, it's no longer being used, but the replica is still there. Additionally, that serves for load balancing between indexes for additional query performance, right? So
load balancing, or could it also be for parallel?
it's not for parallel. Yeah. And we will have probably 5 or 10 minutes here towards the end of the session for all the questions. So any additional questions, please save those for the end. We'll have Perry or Manib walk around with a microphone. But yeah, so and going back to replicas, that serves for load balancing and high availability of your indexes. Full text search, right? Inverted indexes. Our full text search supports a variety of searching, querying in terms of basic, compound, range queries, geospatial queries, custom sorting functionality. And as of Couchbase Server 5.5, there is now over 20 supported languages that are available. And again, this is real-time indexing that is happening asynchronously from your initial mutation to where that data was ingested at. We're able to index, analyze, and query this data, score the results appropriately, return you back matching document IDs, as well as description matches for things like syntax highlighting, etc. And DCP is, or I'm sorry, full text search is a DCP subscriber, right? Just like indexing is. It is a multidimensional scaling service that can be isolated within your environment, right? So, and again, any mutations that are happening, those are happening. That mutation flows through DCP and subsequently gets indexed. Queries with FTS. So any of the FTS nodes that are configured in your cluster can handle a query coming in, and then will perform a subsequent scatter-gather approach to communicate to any of the other FTS nodes that are present in the cluster, retrieve the results, and subsequently return those back to the application. So the application, all it ever knows is there's a single index there, more or less. Okay, for analytics. Analytics is available as a beta service in Couchbase today and in Couchbase Server 5.5. But analytics is slightly different than what you would expect to see from Nickel or full text search. Analytics uses what we call a shadow data set, where it's basically, think of it as just an entire copy of the data set. But we use an MPP architecture, right? Massively parallelized processing architecture, to use all of the available cores for each of the analytics nodes that are present. And this is very good for things like complex queries, large queries, aggregates, but you're able to get near real-time insights on your data throughout your business, right? And perform these queries in a very, very responsive time frame. So when we start looking at this complex processing in terms of a standard architecture that you would see, when all you're doing is parallelizing your query across cores, which is what we do with Nickel. We parallel across cores. On large data sets or extremely complex queries, that could take a minute, for example, for a query to return. But in an MPP-based architecture, we not only parallelize across all of the available cores, but we actually spread that across all of the available nodes that are a part of the cluster. So as your requirements grow, again, you're able to add more, in this case, analytics nodes to service those given requests and meet the SLAs. The ultimate, along with having workload isolation, is that gives you another thing within the Couchbase Data Platform, which is predictable scalability, right? With each one of these services, they serve very specific functions and have very specific needs and hardware requirements, etc. If you know that, for example, Black Friday comes around, I'm going to see a 40% increase in traffic based on the information that you have about your cluster, the size, the document sizes, the number of requests, mutations, etc. You can predictably say, if I add 4 data nodes in this case, that's going to more than handle that additional load. And after that peak, you can remove those nodes from the cluster. You have that elastic scalability and flexibility within the environment. So the analytics service provides a common programming and data model that allows for ad hoc, fast, complex queries, again, workload isolation, and is scalable and secure. So bucket shadowing, which is kind of at the core of analytics, again, is a DCP subscriber, right? And when we use the term shadow, this is a query-specific distribution of the data aggregation, index, and query processing, right? We can take even longer-term data that is persisted while your operational data that's as part of the data service may have expired or been deleted, you can persist that data within the analytics nodes for whatever your SLA is, say 5 years or 7 years or 10 years. This is how long my storage requirements are. And then we keep that operational data, right, continue to turn over. We want to keep that operational data in memory, serve our applications with sub-millisecond response times from the key value service. Next, we have mobile. Right, we talked about this, or you heard about this as part of the keynote today at the Edge, and with Mobile 2.0 that was recently launched, giving you functionality like full text search and nickel queries on the device, being able to perform those actions on the device. Mobile is focused, you hear the term mobile first a lot of times, you know, in web design, right? And we've taken that seriously, and from the Couchbase mobile perspective, it's offline first, right? What good is the app if it requires you to always be online and working? The app should function the same way offline as it does online. And for offline first, whether, let's say you had a given application, you're making a bunch of changes, but you're sitting on an airplane. You should be able to, the moment you get an internet connection, automatically sync those documents and those changes that you made locally on the device back to your Couchbase cluster. And so we have built-in automatic conflict resolution, data-driven alerts as you're receiving mutations, right? Replication, whether it's through HTTP or WebSocket-based replication. Channel-centric access. So say your Couchbase cluster has 1 billion documents in it, but your user that's logging into your given application only needs a fraction of that data, a subset of that data that's specific to them. Call it 100 documents. Through channel-based access, they can authenticate and then immediately start receiving all of those documents replicated from your main cluster down to their client. And then again, as they change data, that can get replicated up. Or it could be a read-only, where you want to basically just preload that given application with data from your main cluster. The Couchbase Mobile encompasses kind of 3 things, which first there is Couchbase Lite. Couchbase Lite is a lightweight embedded database on the device that is basically Couchbase Lite. Couchbase that's in your environment, squeeze down, put on the device, right? Same types of access patterns, right? Key value, nickel, full text search, etc., but specific to the device. And it has all of our replication, technology, etc., baked into there. The next piece, which is key to the mobile ecosystem, is the sync gateway. The sync gateway is more or less a orchestrator between edge devices, mobile devices that are throughout the world, and your Couchbase database. So replication is happening from the device to the sync gateway, right? It's our middle tier. That the change comes from your client to the sync gateway, then sync gateway replicates that change and makes that change actually in your Couchbase server environment. And as those changes happen, right, start thinking about that change might affect another user. So that change all of a sudden now came from one mobile device to another. Think of like a chat platform. That message needs to be replicated to any other users. All of that is managed for you automatically through sync gateway and channel-based access in this case. The next service that I want to talk about is a brand new service to Couchbase as of Couchbase Server 5.5 called eventing. anything from anywhere we can respond to. And the first functionality that we're launching underneath the eventing service is what's called Couchbase functions or functions. Right? There'll be additional features and functionality that will be added into the eventing service as it continues to evolve over time. Eventing is a multidimensional scaling service. And what it's based off of is an event condition action model. Right? I've heard this referred to as a post trigger from a relational world. It's not quite necessarily what it is. There's many reasons why I wouldn't call it a post trigger. It'd be more of a post action would probably be a better analogy for that. So something happens, right? A document changes. A document is deleted. But you want to respond to that. And through a JavaScript-defined function, there's handlers for onUpdate, which handles inserts or updates. And there's also an onDelete handler. So as that mutation happens, we're able to respond to that. Whether you want to get a notification before something expires, or a cascade of deletes, or calling an additional web service call, you'd be able to do that. And this is an extremely powerful functionality that Venkat will be talking about later today. The last thing we want to touch on here is security. The Couchbase Data Platform gives you security across your entire stack in terms of authentication, PAM, LDAP, authorization, right? Support for RBAC for applications was added in Couchbase Server 5. In Couchbase Server 5.5, we have now field level encryption. We also have data at rest through many of our partners, TLS, obviously, administration auditing, log redaction, and full security management through the REST API. So across the stack, including Couchbase Lite, you have AES encryption of the local database, transport over the wire, right? TLS, pluggable authentication and RBAC control. From the middle tier over the wire to Couchbase, we have TLS again, we have role-based access control, secure data management, and geofencing with secure filtered XDCR replication. So end to end, we can address all of the security concerns that you have, especially at this day and age when you have things like GDPR. And if you do want to talk more about GDPR, come find myself or Perry, and we'd be more than happy to discuss that with you. That's all that I have for you guys today. We have, I think, a couple minutes for questions, and then we'll wrap up.
Hi. One question I have is, when you have so many DCP subscribers, is there a way to prioritize? For example, I want my indexing and query to be more responsive than eventing. How do I do that?
In terms of being able to prioritize those and say, go in and configure and say this one's more important than the other, at this point in time, there's not functionality that's supported for that. But that's a feature that we can definitely track.
Thank you.
So is eventing monitoring and how to take action on those monitors, or what is it exactly?
Eventing is being able to put basically compute closer to data. It's basically stateless compute for isolated workloads, meaning I have a bunch of orders that are getting placed, for example, and let's say you're tracking the IP addresses on those orders. Well, instead of your application calculating that, hey, this is a hot listed IP address, or this is from a country that I might not necessarily trust, for example, eventing can flag that after the fact asynchronously through a JavaScript function that you would be able to mutate that document or take the result of that document, put it in another bucket, or potentially even call a web service and respond to a given value or change within a document.
Sorry, so is it manipulation of data based on a predetermined function? Or a
Yeah,
piece
so
of data?
it's an event condition action model. So something happens and you want to be able to respond to your data accordingly, right?
Okay.
And you could use that for monitoring by calling additional external services. But again, it's an event condition action model. So something happens, you have a set of conditions in a predefined JavaScript function that you've deployed to the eventing functions, and now you want to take an action on it. Whatever that action may be, that would be completely up to you. Okay? I think we have time for one more question. If you have additional questions, definitely afterwards come catch me outside.
This will be quick.
Okay.
This will be quick. For the eventing, do you guys have a plan to add it to the the Couchbase Lite?
To Couchbase Lite, at this point in time, I don't believe there's anything with eventing around that. You can respond to, there's already kind of events within Couchbase Lite, so as replications happen, et cetera, or documents are received, you can respond to those. But in terms of like eventing within
Within a mobile device?
yeah, I mean, it's kind of already there in a sense, just based on what you do with SDK. But with what we're doing with eventing here, no. But in the case of you modified a document on the local device, it's then replicated to Sync Gateway, right? Then that mutation goes to Couchbase Server. Then yes, it's going to hit eventing within Couchbase Server. But that's not from the device. That's
This is a server-side event.
yeah, it's basically just an event that happened on the server. We saw that document change, right?
Can you go a little more into shadowing? Like we have a state-based database.
Mhm.
We want to go back, you know, like do some troubleshooting, like what, how the events changed over time, how our data changed over time.
There is a great deep dive session today on analytics at 2:50, I believe. But it is a session that's completely devoted to the analytics service. I would encourage you to go and attend that session. Last one.
So for Sync Gateway, let's say that you have your corpus of documents is like a terabyte. 3/4 of that is available to all of your users. But obviously you don't want to sync all of it. They need to be able to select, I want this offline, I want that offline, and that kind of changes with time, what they happen to have locally. Is that covered, that use case easily covered with Sync Gateway?
Yeah, so you have a terabyte of data and you want 3/4 of it to be publicly available, to be synced, or publicly available in the sense of your application, right? I'm sure Apple would love us to have, 750 gigabyte iPhones, but I don't think that's going to happen anytime soon. So yeah, there's definitely different strategies in place for saying, hey, I've viewed this document, right? I want to write it to my local database. And even in terms of Sync Gateway, right? You can have just the Couchbase Lite database on the phone, and there's not necessarily replication involved. It's not forced replication. I mean, we're not saying you have to move this to here. And so, in terms of like an active, ongoing, replication, so you would be able to define a strategy to say, oh, I've viewed this product recently, for example. Let me make sure this is stored on the user's device, and then a change may happen to that product, right? A price change. So that price change happens. You say, oh, now I want to show an alert to the user that this product's on sale, et cetera. I think we're going to wrap up, but you can catch up with me after this session? It'll be good? All right.
Okay, thank you, Aaron.
Thanks,
you all
guys.
for your questions and engagement.